In this video, I'm going to run through one more example of algebraic long division before I talk about the remainder and the factor theorem. I think I already touched on the factor theorem once, in that if the remainder is 0, then I know the divisor is a factor of the dividend. Alright, so here I have a remainder of 5. So I know that x to the third minus 2x squared plus 5x plus 1. I guess I could write the divisor here, x minus 1. I know this is going to be equal to the quotient, x squared minus x plus 4 plus the remainder divided by the divisor, or 5 divided by x minus 1. Or if we wanted to multiply both sides of this equation by x minus 1, then I would get the dividend is equal to the quotient times the divisor plus the remainder. And so let's show what I mean by that. If I have some polynomial p to the x, and I divide it by x minus a, same way I did here. So a is -1, a is positive 1 in this case. Then I know this is going to be equal to some other polynomial q of x, which is the quotient that we get after the algebraic long division, plus the remainder divided by x minus a. So this is in the same form as this right here. And I can also write this as this polynomial p to the x is x minus a times the quotient plus the remainder. I think I've wrote it like that before as well. The main reason I want to write it like that is because I want to then take a look at what p of a would be. Well, I would just have a minus a and then evaluate it at q of a, but this is 0, a minus a, so it doesn't matter what q of a is. I'm just going to be left with the remainder. In other words, that polynomial evaluated at a is going to be the remainder. And so this is the remainder theorem, and we're going to use this to get into synthetic substitution. So if you remember synthetic division, if you remember when I did synthetic substitution, let's do that for p of a right now. So we know a is 1, positive 1, since it's negative here in the definition. So this will be the synthetic substitution. I'll show how it's related to this algebraic long division and how we can even use it as a shorthand for it rather than... This seems like a lot more writing than just the synthetic substitution. So if I remember correctly, we have a line here, then we drop the 1 down. If you remember, this is evaluating a polynomial at a. We can write the coefficients, drop the first term down, and each time we go in this direction, we multiply it by the number we're evaluating at. And if you remember why, it's because we can represent these as nested linear terms. And so every time we move into the next larger linear term that our smaller linear term is nested in, we're multiplying by x and then adding a constant. Multiplying by x, adding the constant. This is the x value. So 1 times 1 is 1, and then we add up the constant. -2 plus 1 is -1. -1 times 1 is 1. And we have a 6. Oh wait, did I do that wrong? Negative 1 times 1 is negative 1. And then I have a 4. And then 4 times 1 is 4. Add it up and we get 5. Alright, so this is synthetic division. And I just want to point out a few things here. This is going to be our remainder. And this is the opposite sign of this is going to be, this is A. If this is x minus A, then this is going to be A. And then each one of these terms here represents our quotient. And the reason that works is because this is the exact same process of what we were doing here with the algebraic long division. When I drop the 1 down, that's the same as me writing a 1 up here, because I'm recognizing that in my dividend I have a coefficient of 1, and in my divisor I have a coefficient of 1 in front of x, because that's we're always going to do it with a coefficient of 1 in front of x. So the question is, how many times does x go into that coefficient of the first term in my dividend? So it'll always be the coefficient of the first term in your dividend. So you drop that 1 down. And then the process of multiplying by 1 and writing here and then summing it is the exact same as here. Because this is minus A is already included in the definition of this, we know that's why I'm always subtracting away. So the sum is actually a difference over here. So negative 2 plus 1 is the same as negative 2 minus, or if you could see this as if I had distributed in the negative, it would just be negative 2 plus 1. And then same here, 5 minus 1, 5 minus 1. 1 plus 4, 1 plus 4. So this is just kind of a shorthand for the algebraic long division that we did. If it's in the form of x minus a, the coefficient in front of x is 1. This is going to be important later because it helps us evaluate these polynomials really quickly. And really it's mostly important if you want to find all the factors of a polynomial. And I might do a video on that, explaining how to find all the rational factors. And then as we get into calculus, we'll find more ways to estimate irrational factors of polynomials. So if we were to write, if the goal was to write a program that finds all the roots, all the real roots of a polynomial expression, first you could use techniques like this, and I'll get into how to find all the cases, all the potential factors looking at a polynomial at a dividend, how to find all the potential factors, all the potential a values is what I mean, that we can divide out of that polynomial and find the rational roots. But many times you're going to have irrational roots, and in that case we're going to have to turn to calculus to use techniques to estimate the irrational root. Unless you can boil it down to, unless you can factor out some real roots or some imaginary roots and get it into a quadratic, and then you can use your quadratic equation to find out exactly what those irrational numbers are. But I might go into more depth on polynomials, I'm not sure, but I just wanted to do an introduction into synthetic division. This is synthetic division, just a shorthand for the algebraic division. Is there anything else I need to say on this? Oh, one more thing, the factor theorem. So the factor theorem states that if the remainder is 0, then we know p of x can be written as x minus a times q of x. In other words, x minus a is a factor of p of x.